November 1950 began as a typical late autumn period across the Appalachian region. Coal trains moved through mountain passes on fixed schedules. Electric transmission lines carried power from generation stations to urban centers across Ohio, Pennsylvania, West Virginia, and neighboring states. Highway traffic followed seasonal patterns. Temperatures ranged from the mid-30s to low 50s Fahrenheit. Snow removal equipment sat in municipal yards, prepared for the winter season ahead. The regional transportation network operated under the assumption that weather systems would develop gradually, allowing time for operational adjustments. Power distribution systems functioned within normal capacity ranges. No unusual atmospheric conditions had been forecast. The Appalachian region in 1950 encompassed portions of 11 states, stretching from southern New York to northern Alabama. Winter weather patterns typically brought moderate snowfall to higher elevations, with valleys receiving mixed precipitation. Average November snowfall in Pittsburgh measured 2.3 inches. In Charleston, West Virginia, the figure stood at 1.1 inches. Wheeling, West Virginia recorded an average of 3.8 inches for the month. These figures represented accumulations over the entire 30-day period, not single-event totals. Transportation infrastructure relied on coal-powered steam locomotives for freight and passenger service. The Baltimore and Ohio Railroad operated main lines through the region. The Pennsylvania Railroad maintained parallel routes. The Chesapeake and Ohio Railway connected coal mines to eastern ports. These systems moved an estimated 400,000 tons of coal per day during November 1950. Highway networks consisted primarily of two-lane roads with limited grade separation. The Pennsylvania Turnpike, opened in 1940, represented the most advanced highway engineering in the region, but covered only 160 miles. Electric power generation centered on coal-fired steam plants located near fuel sources. Transmission systems used overhead lines mounted on wooden poles or steel towers. Voltage levels ranged from 23 kilovolts for local distribution to 138 kilovolts for regional transmission. The grid operated as interconnected regional systems rather than a unified national network. Cold weather increased electrical demand for heating and lighting. Utilities planned capacity based on historical peak loads, which typically occurred in January or February. Snow removal capability varied by jurisdiction. State highway departments owned rotary plows and truck-mounted blades designed to clear accumulations up to 12 inches. Municipal systems operated smaller equipment suitable for urban streets. Rural roads received lower priority in snow removal hierarchies. Most equipment required manual operation with limited mechanization. Salt and chemical applications remained limited compared to later decades. Sand provided the primary traction enhancement material. On November 22, 1950, a low-pressure system developed over the Ohio Valley. Surface pressure readings dropped to 997 millibars at Columbus, Ohio. Simultaneously, a cold Arctic air mass moved southward from Canada. Temperature readings at International Falls, Minnesota, fell to -11 degrees Fahrenheit. Wind speeds increased as the pressure gradient intensified between the cold high-pressure system and the developing low-pressure center. The low-pressure system tracked eastward along a path from Cincinnati toward Pittsburgh. Moisture from the Gulf of Mexico moved northward along the system's advancing warm front. When this moisture encountered the Arctic air mass, rapid condensation occurred. The freezing level dropped to near-surface elevations across the entire Appalachian region. Precipitation that began as rain in southern areas transitioned to snow within 2 hours. By November 23, the low-pressure center had deepened to 989 millibars. Wind speeds exceeded 40 miles per hour across exposed ridges. The temperature differential between the Arctic air and the warmer moisture created conditions for heavy precipitation rates. Snow fell at rates exceeding 2 inches per hour in some locations. The storm system moved slowly, maintaining heavy precipitation over the same geographic areas for extended periods. Atmospheric conditions prevented the usual eastward progression of the storm system. A high-pressure ridge over the Atlantic Ocean blocked the low-pressure system from moving off the coast. This meteorological pattern, later classified as an omega block, forced the storm to remain stationary over the Appalachian region. Precipitation continued for periods ranging from 36 to 48 hours, depending on location. Temperature readings remained in the range of 18 to 26 degrees Fahrenheit throughout the event, preventing any melting of accumulated snow. Railroad operations in November 1950 depended on maintaining clear tracks and functioning switches. Snow accumulation exceeding 6 inches created operational difficulties. Accumulations beyond 12 inches required specialized rotary plow equipment, which many rail lines did not possess in sufficient quantities. Switch points froze when snow melted from train wheels and refroze as ice. Signal systems lost visibility when snow covered lenses and indicators. The electrical grid's vulnerability centered on overhead transmission lines. Ice accumulation on conductors increased weight loads. Wind pressure against ice-coated lines created additional mechanical stress. Wooden poles supporting distribution lines had load ratings calculated for normal winter conditions, not extreme events. The combination of heavy wet snow and wind speeds exceeding 35 miles per hour approached or exceeded design limits for many structures. Highway systems lacked continuous snow fences or wind breaks. Roads following valley floors accumulated drifting snow from adjacent slopes. Mountain passes experienced reduced visibility and rapid accumulation rates. The ratio of snow removal equipment to road miles stood at approximately 1 plow truck per 50 miles of state highway. This capacity allowed normal winter maintenance, but could not address simultaneous heavy accumulation across entire regions. Coal supply chains required continuous movement from mine to power plant. Most generating stations maintained coal supplies sufficient for 3 to 7 days of operation. Rail disruptions directly threatened power generation capacity. The interdependency created a failure scenario where transportation problems caused power outages, which in turn disrupted pumping stations and signals needed for transportation recovery. Urban areas concentrated population in grid patterns served by radial transportation routes. When these routes became impassable, no alternate access existed. Food distribution systems operated on daily or twice-daily delivery schedules with minimal inventory held at retail locations. Medical facilities depended on external supply chains for most materials. Communication systems used above-ground telephone lines, vulnerable to the same weather conditions affecting power transmission. Snow accumulation reached 6 inches across the Pittsburgh region by 1800 hours on November 23. Rail operations began experiencing delays as switch points froze. By 2200 hours, accumulation exceeded 12 inches in Wheeling, West Virginia. The Baltimore and Ohio Railroad suspended all passenger service on its main line between Cumberland and Grafton. Freight operations continued at reduced speeds until 300 hours on November 24, when 3 separate trains became immobilized by snow depths exceeding 2 feet. Power outages began at 1:45 hours on November 24 when a transmission line near Morgantown, West Virginia, collapsed under ice load. The failure cascaded through the regional network as adjacent lines absorbed the redistributed electrical load. By 600 hours, portions of 14 counties in West Virginia had lost power. The Monongahela Power Company reported 47,000 customers without service. West Penn Power recorded outages affecting 63,000 customers. Highway closures expanded systematically as snow depths overwhelmed plowing capacity. The Pennsylvania Turnpike closed between Carlisle and Irwin at 800 hours on November 24. U.S. Route 40, the primary east-west highway through the region, became impassable in 17 separate locations between Wheeling and Uniontown. State Route 2 along the Ohio River closed completely. By midday November 24, all major highways in a 12-county area of southwestern Pennsylvania and northern West Virginia had been declared impassable. Temperature readings remained between 19 and 23 degrees Fahrenheit throughout November 24. Wind speeds sustained at 30 to 35 miles per hour created drifting conditions that refilled recently plowed roads within 2 hours. Snow accumulation rates decreased to approximately 1 inch per hour, but continued without interruption. Total accumulations reached 30 inches in Pickens, West Virginia, by 1800 hours. Areas along the eastern slopes of the Alleghenies recorded 36 inches. Communication system failures followed power outages. Telephone exchanges operating on battery backup functioned for periods ranging from 4 to 8 hours before capacity exhaustion. Manual switchboards requiring operator power could not function during electrical outages. By evening of November 24, telephone service had failed in 73 communities across the affected region. Radio stations operating on emergency generators provided the only remaining mass communication capability in most areas. Coal delivery interruptions affected power generation within 48 hours of rail system failure. The Rivesville Power Station in West Virginia exhausted its coal reserves by November 26. The Fort Martin Station reduced output to 40% of capacity. The Albright Power Station suspended operations entirely. Combined generating capacity dropped by an estimated 340 megawatts across the Monongahela Power Service territory. Similar reductions occurred throughout the regional grid. Food distribution systems failed when truck transport became impossible. Retail food stores in communities with populations under 5,000 typically maintained inventory sufficient for 2 to 3 days of normal sales. With roads closed and no resupply possible, shortages of bread, milk, and meat products appeared within 36 hours. Larger urban centers maintained somewhat greater reserves but faced the same trajectory. By November 26, food shortages affected an estimated 800,000 people across the region. Medical supply chains experienced similar disruption. Hospitals in Clarksburg, West Virginia, reported exhaustion of oxygen cylinder reserves on November 26. Blood supplies dropped below operational minimums at facilities in Morgantown and Fairmont. Pharmaceutical inventories designed for normal usage patterns could not be replenished. Emergency medical transport became impossible except by foot in most areas. Ambulance services in 41 communities suspended operations due to impassable roads. The geographic extent of system failure expanded beyond the area of heaviest snowfall. Communities that received only moderate accumulation lost power due to failures in transmission lines originating from heavily affected areas. Transportation disruptions prevented repair crews from reaching damaged infrastructure. The Cumberland, Maryland, office of the Chesapeake and Ohio Railway reported 87 separate locations requiring track clearing, but equipment could not be moved to these sites. Manufacturing operations dependent on continuous power supply or material delivery shut down systematically. Steel mills in Weirton and Steubenville reduced operations or suspended production entirely. Glass factories in the Ohio Valley region went cold when natural gas pressure dropped due to pumping station power failures. An estimated 67,000 manufacturing workers across the region experienced work stoppages directly attributable to storm impacts. The economic effect compounded as supplier networks extending beyond the immediate storm zone experienced interruption. The storm directly affected populations in portions of 11 states. The core impact zone encompassed approximately 1.2 million people in Pennsylvania, West Virginia, Ohio, and Maryland. Snow accumulations exceeding 20 inches covered an area of roughly 25,000 square miles. An estimated 450,000 people lost electrical power for periods ranging from 3 days to 2 weeks depending on location. Casualty figures compiled by state health departments and civil defense agencies recorded 353 deaths directly attributed to the storm. Hypothermia accounted for 127 of these deaths. Carbon monoxide poisoning from improvised heating methods caused 83 deaths. Cardiovascular events during snow removal activities resulted in 91 fatalities. Traffic accidents during the initial storm period caused 34 deaths. An additional 18 deaths resulted from structure fires related to emergency heating attempts. Evacuation operations began on November 25 in communities where combined power failure and heating fuel exhaustion created life-threatening conditions. The town of Parsons, West Virginia, evacuated 742 residents to emergency shelters in less affected areas. Terra Alta, West Virginia, evacuated 468 people. These operations required tracked military vehicles borrowed from National Guard units. Standard wheeled vehicles could not navigate the snow depths. Total evacuation numbers across the region reached approximately 5,400 people. Infrastructure damage assessment conducted after snow clearing identified 2,847 collapsed or damaged electrical transmission and distribution structures. The Allegheny Power System reported 348 broken poles. Monongahela Power documented 521 separate outage locations. West Penn Power recorded damage at 412 sites. Railroad infrastructure damage included 73 derailments, most occurring as trains attempted to operate in deteriorating conditions. Highway departments reported 1,284 locations requiring structural repair beyond simple snow removal. Economic loss calculations performed by state agencies totaled $66.7 million in 1950 dollars. This figure included infrastructure repair costs, lost industrial production, livestock losses, and documented property damage. The figure did not include indirect economic effects such as delayed deliveries, contract penalties, or regional economic slowdown. Agricultural losses centered on livestock mortality, with reports documenting 4,200 cattle deaths and 1,800 sheep deaths across the affected region, primarily due to exposure and inability to deliver feed. Snow removal operations began in earnest on November 27 as precipitation ended and temperatures rose above freezing in lower elevations. State highway departments mobilized all available equipment, supplemented by private contractors operating bulldozers and front-end loaders. The Pennsylvania Department of Highways deployed 412 pieces of equipment to the affected region. West Virginia deployed 287 units. Priority went to primary highways, connecting urban centers and routes accessing isolated communities. Main highway routes reopened on a staged basis between November 28 and December 3. The Pennsylvania Turnpike resumed operations on November 29. U.S. Route 40 reopened to single-lane traffic on November 30. Secondary roads and rural routes remained impassable in many areas until mid-December. Some mountain roads did not receive clearing until late December when spring thaw would naturally occur. Total snow removal costs exceeded $8.4 million across the affected states. Electrical service restoration followed a systematic process of line inspection, structural repair, and staged energization. The largest power systems achieved 90% restoration by December 5. Smaller rural systems required longer periods due to greater structural damage and limited repair crews. The last communities regained electrical service on December 18. Total restoration consumed 47,000 worker hours from utility personnel and 23,000 additional hours from contractor crews. Railroad operations resumed more rapidly on main lines, but faced extended delays on secondary routes. The Baltimore and Ohio Railroad restored through service on its main line by November 29, operating at reduced speeds through cleared but not fully restored sections. The Chesapeake and Ohio Railway achieved similar restoration by November 30. Branch lines serving coal mines in mountainous terrain required longer clearing periods. Some mining operations remained inaccessible until December 8, creating extended coal supply disruptions. The U.S. Weather Bureau issued its official summary on January 15, 1951. The document recorded maximum snowfall totals of 57 inches at Coburn Creek, West Virginia, and 52 inches at Pickens, West Virginia. The report noted that 23 official weather stations recorded snowfall totals exceeding 20 inches during the event. The summary identified the meteorological pattern as resulting from an unusually deep low-pressure system, combined with blocking atmospheric conditions. The document made no specific recommendations for infrastructure modifications or emergency preparedness improvements.